I'm actually going to start the class, so if anybody else joins in. So, hello everybody. What a crazy week. Like, holy welcome back from your winter break. Smash right into a brick wall for you. Crazy times happening out there. I'm assuming most of you are in data literacy or starting data literacy. So you have about 3 weeks before you're going to be starting this topic, but we wanted to give you lots of time to play with it, especially if you're new at representing these visually. Michelle will be monitoring the chat today. So if you do have any questions, please do not hesitate to put them in the chat or even unmic and speak up. She will either address it right there in the chat, or we will make sure that we address it at some point. It might be helpful for you to have some graph paper and a pencil handy. We know that you're at home and you probably don't have a stash of graph paper available, but any kind of paper will do. Graph paper would be the best. Let's move forward. Okay, so here are the faces of Learning Support Services in case you haven't been to one of these before. Michelle and myself are the ones who help support intermediate math. Hebron that you see there in junior also supports some intermediate math in distance learning, but he's doing the just-in-time PD sessions for junior. And we're still waiting to see who his partner is. They've just hired some new people and we don't know who that is yet. Today's menu, we're going to look a little bit about some background in fractions, and then we're going to look at how you can develop the operational sense of your students. And spoiler alert, we actually had some questions on the Slido this time around. So we do have some questions that we are going to address at the very end. Now, in the top right corner there, you might see a green square and a red square. This was shared with us by Jessica Webb with some of the distance learning teachers in an intermediate session that she was doing. So I thought I would share it with you today because many of you are now in a position where you are using slide decks in a virtual environment. And the purpose behind these green and red squares are you can put this little icon on each slide. And if it's a slide that you just want to, you just have to get some instructions out, you're just trying to talk to the students, then you put a red square there. And that's an indication to them that this is a slide that I don't want you to ask any questions. You'll have an opportunity to ask questions later. And then if it's a slide that you're opening the chat or you're open to them unmiking and asking questions, you can have a green square at the top of that slide. And that's just a little visual cue for them so that you're not constantly like hearing the chat go or having to check things. So because I'm so open and I'm such a friendly person, I have put a green square on every single slide here, so you can ask questions on any slide that you want. There is no restrictions today for that. So let's take a moment here just to think about, like, why are fractions so tricky? Why is it that every time students show up to your class, especially in grade 7 and 8, they look at you like they've never seen a fraction before in their life, and then they try and operate with them like they've never seen a fraction before in their life? And I think there's a lot that we as teachers and we as adults take for granted on the depth of knowledge we actually have of fractions without even realizing that. So there's a book, a little pamphlet, it's called Paying Attention to Fractions. This is actually a live link. So if you clicked on that Paying Attention to Fractions icon up there, it would take you right to the PDF. It was created by our ministry, and it's a really good condensed overview of like what fractions really are all about, even though we think we are. So one way, when we put a fraction in front of a child, one way we might think about that fraction is as a part to whole relationship, where the denominator is telling us how many pieces it takes to make a whole, and the numerator is telling us I have this many pieces. So the bottom example here is 7/9. It takes 9 pieces to make this bar completely shaded, and I have 7 of them shaded. That's how most students are exposed to fractions. That's how we interact with fractions the most in a formal school setting. And that's a little bit unfortunate because there's lots of other ways that we think about fractions as adults that we don't realize we're doing it this way. And we're not making it explicit to students, so they get totally confused because they're just starting to understand what we're talking about with a fraction. And then boom, we're using it in a different context. And I'm going to show you some of those in a moment. Let's also remember that the students we have in front of us right now have not actually been formally introduced to fractions in the sense of writing it down symbolically and manipulating it symbolically. until grade 4. That's the 2005 curriculum that we were working with. So the students that are in front of you have not had very many years to play with this concept of fractions. And you have had decades. Even if you're a young teacher, you've still had decades. If you're like me, you've had a lot of decades. Another way we use fractions, and we don't necessarily do this enough with our intermediate students, is as part-to-part relationships. So if you're looking at this picture down here of the fruit, it's saying that the number of fruit in this set that are pairs is 3/6 the number of fruit that are not pairs. So it's a ratio, 3:6. And students will sometimes use a fraction as a part-to-part, and we mark it wrong. And we tell them that that's not right. And actually it is, unless we've given them the context of it being part to whole. Did you know that a fraction is actually a division question? So if we're looking at 6/3, that's 6 divided by 3, that's 2. We can intuitively do that. Students are not even aware. Like, we are talking about a major operation here that they've been exposed to only through seeing this division sign. And now we're looking at a fraction and going, well, that's 2. You get that, don't you? They're like, no, I thought this was a fraction that you put on the line. And I thought that meant that it takes 3 pieces to make the whole, and I have 6 of those pieces. So it's all very closely interrelated, but it's not to students, and it's not intuitive to students. And the last thing that we think about fractions is as an operator. So if I'm talking about 1/3 of something, now I'm actually talking about a multiplication question. So when I'm saying to a student, I want 1/3 of that set, again, we're blowing their minds, because 1/3 just means this is where it lands on the number line. Or if I have a set of something, it means one of them's blue and the other 2 are not blue. Okay, so I'm just saying these, and if this is kind of a new way for you to be thinking about fractions, I do recommend that you take a few minutes and read that, Paying Attention to Fractions. It's not a very long pamphlet, but it is full of really great information. And just thinking about all the ways we interact with fractions that students have not had experience doing. So here's a real life example of exactly what we're talking about. I'm just going to give you a second to look at this. And just if you see something, either unmic and speak up, or just write in the chat, like, what are you noticing about this test? It was actually brought to the teacher by a parent. Anybody have anything they want to share about this that they're noticing? Okay, so I'll share something then. So clearly this student in part A has got 4 out of the 5 questions correct. And in part B, they've got 3 out of the 5 questions correct, which gave them a mark of 7 out of 10. But if you actually look at the question in part A that they got wrong, it's exactly what the teacher has done to get the mark. And this is what students see over and over again. But then we're telling them, no, that you don't add the denominators, you add the numerators. So when we teach students by rules like that, and only a set of rules that are, you either do it like this or you don't do it like this, it's confusing to them when they see something like this. So we haven't developed their operational sense of fractions by just teaching them the rules of fractions, and we haven't taught them to think in a fractional way, which is actually also in a proportionate way. So those 4 non-negotiables, that proportional reasoning piece is so big. So what's happened here is we have 2 part-to-part fractions. So 4 to 5 and 3 to 5 are 2 part-to-part fractions that we've added together to get a part-to-whole fraction. So this actually was brought back to the teacher by a parent who looked at this and said, you've done exactly what you're telling my child is wrong. We do it all the time. This is, if you're somebody who gives tests and gives them marks like this is what they see all the time. But then you're giving them a contradicting message in class. So again, just something to think about all the ways we interact with fractions as adults that are common to us and make sense to us, that we're exposing students to that don't make sense to them. So let's not always blame students for the fact that maybe when they're sitting in your class and looking at you with a blank stare, that they don't know what you're talking about with fractions. Maybe they don't, because of all of the context that you're talking in. This was a tweet that was put out by Kathy Bruce a few years ago, and it's talking about how much more successful students are with fractions when we revisit them over the course of a year, as opposed to just teaching it as a unit in the fall and never coming back because you've already taught your fractions unit. So when we think about, here we go, the long range plans, we have our 4 non-negotiables for intermediate that are in the circles here. We have embedded them in each of the topics as best that we possibly can. So you are revisiting it through the content that you're teaching in each of these topics based on the expectations that are there. But are you actually continuing to assess the student's level of understanding of these things? So what you need to think about is, how are you coming back to revisit these 4 concepts? And then how are you observing or hearing or seeing students interact with these 4? And Alita Klassen, who's one of our secondary teachers in at WCI, she created this visual, and I really like this visual as a way of thinking about multiple opportunities to be revisiting these topics. And I'm just going to take a moment to explain it to you. We in elementary don't really focus on the rainbow thing that's going on at the very end of each row. That would be their final exam, that they have to give a 30% summative in secondary. We don't have to worry about that in elementary. But the top row demonstrates how we've traditionally taught math. We've taught in a unit. So red might be integers, orange might be angles, yellow might be fractions, and so on. And when we're finished it, we give an assessment, and then we move on to the next topic. And it's like Kristen Phillips used to always say, it's like when you have to go back and change your clock on your car radio, or on your car radio. You only have to do that like twice a year. So nobody ever remembers how to actually do it. And you're pulling out the manual and you're doing it because you're not being exposed to that constantly. And it's the same thing when you're teaching fractions as your unit, and then you don't touch it again until they hit fractions again the next year. They're not out there in the world using fractions the way we might be using fractions. So it actually does go quite blank for them. The third row, skipping the second row for a minute, this is a spiraling approach to teaching math in which, and some of our grade 9 applied teachers do this, they go through the entire curriculum 3 times in a semester. And each time they hit it, they go a little bit deeper into the content area. So that's what you're seeing there. They would be addressing everything in the curriculum at a shallow level that first time around, then they would give some sort of a formal evaluation about it. They would hit it a second time, go a little bit deeper, and then by the third time, they've gone really deep into it. That takes a really skilled teacher, and that takes a lot of time for you to set up. It's a great way of approaching math. It might not be where you're at right now, but this middle row is something that I feel all of us could be doing, especially with the 4 non-negotiables, and probably only worrying about the 4 non-negotiables right now. So we started our year off teaching integers. That's the red piece right there. And then we probably did some sort of an assessment on integers. Then we moved into algebra. Well, what if on the algebra summative, we actually added some integer questions back on? It doesn't even have to be embedded in the algebra content. It could just be like a couple extra questions that you're adding that students are being forced to rethink about again. And then we moved into geometry. In geometry, on your geometry summative, you could add in some algebra questions and you could add in some integer questions. And then we moved into adding and subtracting fractions. So I think you get the idea here. Each time you're giving a summative, how can you put a couple of these 4 non-negotiable questions on so that you can continue to revisit and assess how students are doing with these concepts and their level of understanding? So that all of a sudden next year, they're not thrown into grade 9 or in a grade 8 situation and forgetting what we were doing. Are we good, Michelle? Were there any questions around any of that? Because that green box is up there if anybody had questions.
Yeah, no one's had any questions so far.
Are people still with us?
I think so.
Okay, good. We haven't lost anyone. That's good. Okay, so that was just a little bit of fraction background, something for you to keep in mind, something for you to think about. And now we're going to move into developing operational sense. And so what tends to happen with fractions is most of us were taught in a way that was very rule-based, very procedure-based, very algorithmic. And that worked for some of us. It did not work for the majority of the population. If you are teaching intermediate math, I'm going to assume that it probably worked well for you because you were good at remembering rules and memorizing rules and knowing when to apply them. But what that doesn't do is actually develop the operational sense of the student. And that's our job in elementary. Our job is to give them an understanding of what multiplication really means and what division really means. And we started thinking about this back when we were doing integers. We talked about how division could be quotative or partitive, right? It could be thinking about, I'm taking this whole and I'm dividing it into this many groups, or I'm thinking about how many times this part goes into this whole. That's how we don't want just to be teaching them rules for how to divide. We want them to become thinking. So when a division question comes up, they know it's a division question because they're thinking about it in that way. They're not looking for keywords in a word problem, or they're not trying to remember what rule is it that I apply right now. They fully understand what it means to be doing a division question. So this should look familiar to most of you, I would think. This is how most of us were taught. This is maybe our only go-to strategy still, so I'm glad you're here if that's the situation. But this, if there was ever a malpractice suit in teaching, this is it right here. When I look at this mathematical problem, and I'm telling kids, hey, guess what? It's okay. You just change the operation in that. That's fine. Change it from division to multiplication. And you know what? Take that second fraction and just flip it over. Change the entire number there. That goes against every single law of mathematics. That is a mortal sin in mathematics. Nowhere else would we allow them to just change the operation or to change a number on its own and just move forward and say, yeah, that's okay how we do it. Again, another mixed message that we're giving to students. So in one situation, if they try to do this with an adding or subtracting question, we would lose our mind on them. But then they don't understand, well, why can I do it with division and multiplication? It's not a bad thing for students to know this, but this isn't the only strategy you give them. And this isn't where you start, or you've just gone back to creating a situation where math doesn't make any sense. On top of that, when we realize, oh, you know what, kids might forget this rule, let's teach them a little rhyme. Yours is not to reason why, just invert and multiply. This was actually taught to students. Maybe some of you here with us today. Yours is not to reason why. What kind of schooling is that when we're okay with saying, don't ask why, just do this? Like, so this is the history of mathematics. This is why fractions don't make sense. And this is why everybody says, I don't get math. I'm no good at math. This right here explains it the best that I know how. So we are going to look at how, instead of teaching them that rule, can we develop the operational sense and get them to that rule? Because it's, like I said, rules are great to know. But when it's the first thing introduced to them and it's their only go-to strategy, that's when math doesn't make sense. So here's some useful manipulatives. You have access to all, these are all linked. So you would have access to all of these that you can peruse and play with later. Today, we're not going to focus on the concrete representations because we're kind of living in a virtual world. We're going to focus more on the ones on the right side, these useful visuals and tools. And just to reiterate, when students create concrete and pictorial representations of mathematical ideas, provide teachers with valuable assessment information about student understanding that cannot be assessed effectively using paper and pencil tests. So if your experience in math for multiplying and dividing fractions was simply a test that had maybe 20 different multiplication and division questions that you just answered and put the answer in the blank, and then maybe 2 really convoluted, not making sense word problems, your teacher did not adequately see your level of understanding of these kind of operational sense. And if you looked at that slide way back that had division turning into multiplication, and you're like, yeah, that's how I taught, but I don't really know why that's what I was taught, but I don't know why that works, then this is speaking to that as well. You were never able to develop a great operational sense of division. So how do we do that? Well, for one, we're going to stop asking them for the answer we're going to get them to prove the answer. So I'm going to give you the answer and I want you to prove to me visually. This is also great for our Kumon kids, right? Those kids who already know, hey lady, I already know this algorithm. I don't want to spend any time drawing any figurines down here. Let me just do it the way I know how to do it. Yeah, that's great that you know that algorithm. Prove to me why that works. That's a different question for these students when they have to prove it to you. So what we're going to do right now is I'm going to let you choose your own learning adventure here. If you are already familiar with how to use a number line and area model to prove this question, then I'm going to challenge you to choose technology. So the one link goes to an online number line. The other link goes to Equatio. And I'm going to challenge you to use those technology to broaden your understanding of how we can use technology to do this. If you're totally new to using a number line and an area model, you might want to start with just pencil and paper, and that's totally fine, just so that you can play with the idea. Feel free to use the tech as well, but I don't want you learning the tech to get in your way of you learning how to visually represent these things. So I'm going to let you go now. There's a classroom slide deck. Let's just go to the classroom slide deck for a minute. Click on that link. The classroom slide deck, eventually I'm going to ask you to put a picture of how you've represented this question, how you've proved it onto your slide. And I have instructions here on how you could, if you've done pencil and paper, how you can just upload an image of that pencil and paper. If you choose to go to area model and use Equatio, then you can actually, maybe actually come back to the meetup right now so you can see what I'm doing. Yep, I'm still presenting. Okay, come on back to the meetup right now. I took a wrong moment to go back and visit the meetup because somebody was like totally rubbing their head really hard. I hope everyone's still okay. Someone looked like they were bewildered. Okay, if you're using Equatio, if you have the Equatio add-on, and if you don't, I highly recommend it. It looks like this little blue square. It will come down here, and you can actually go to this space right here, which when I click on it, it opens up what's called Math Space. And then I can use these smart shapes, which come out as a fraction bar. And I can decide how many segments I want and how many of those segments I want shaded. And then when I'm finished creating my diagram, I can just click on this blue button here and it will insert it back into my classroom slide deck here. I can even show you that, if that makes sense. So if I click on insert, you're gonna see, boom, there it comes up on the Google slide. How cool is that? So if you're using Equatio, you're gonna insert it like that. If you go to the number line, I want you to take a screenshot and bring it back here. I'm gonna give you 5 minutes and I'll check in with you at that time. And if you're fully lost, say, I don't have a clue where to even begin, and Michelle and I will help you out. And I just want to remind you, I'm not meaning to interrupt. I'm hoping I'm giving you a hint. Remember that a division question, 2/3 divided by 1/4, 1/4, is asking how many times does 1/4 go into 2/3? Can you prove that to me? How can you show that to me? Okay, I see a couple here in the Google slide deck that I'm super interested in. So if everybody could go, I'm not sure who's owning the slide, but we're going to go to the house of 7. So if you can go to the slide number 7.
That's me, Rhonda. Caitlin.
Oh, hey, Caitlin. Can you explain to us, Caitlin, how you've thought about this?
I can try.
All right.
So I created oh gosh. So I created the 2/3 first and then had the the quarter bar on top of that. And I could see that, okay, quarters are not going to fit equally into the thirds. So then I thought about how I could relate thirds and quarters, and that was through the 12ths. So I added that bar there to show. And then I guess my thinking was, okay, from there, I can see that what would fit into the 2/3 is like two quarters, like 2 of the quarters, and then another 2/3, if that makes sense.
Yeah, it totally makes sense. Thank you. So what you're looking at is you've seen that 1/4 is 3 of those bars. And then if I'm looking down at the 2/3, I can see it's 6 bars, which is 2 of the 1/4 units. But then I have 2 more bars right here. So it's not a full 1/4, it's only 2/3 of a 1/4. So 1/4 fits into this 2 whole times and then 2/3 of a 1/4. That's a really tricky concept for students. And when we just teach them to flip and multiply, they don't even understand what that number is that just came out. Like, amazing. Thank you so much, Caitlin. There was another one, I think, Sheila. Can we go to slide number 6 right next door here? And Sheila, can you explain to us how you were thinking about it?
Yeah, can you hear me?
Yep.
Okay, so what I did was I made 2/3, so you can see that this part right here, I made it into 2/3, and then I made the 2/3 into quarters. And so then you can see that I circled each of them because 3/3 is 1. So there's 2 there, and then there's 2/3 left over. Does that make sense?
I don't know if I got it.
No.
Okay, so I drew 2/3 to start with.
Okay, so let's
Okay.
stop there for a second. So you drew a rectangle,
Yeah.
and then your vertical lines have divided that into 2/3, right?
Yeah.
And then you've created like those diagonal dashes to emphasize.
So that it was 2/3. Yeah.
Okay, you got us there.
Okay, so then I took my 2/3 and I divided that each into a quarter so that there were 4 quarters.
So this is the horizontal lines now.
Yeah.
Okay.
Okay. And so you can see that I know that 3/3 is a whole, so that there's 2 sets of 3/3 and there's 2/3 that I haven't got circled. Can you see this part, what I'm doing?
We can't see
see
you.
it. I can see it, but the thing that I'm stuck on is the 3/3 is a whole. Like, tell me more about that circle that you've drawn.
Because I don't know, because it made sense to me when I did it. I'm not sure that I can explain it that way. Michelle, can you explain it? Can you think of how I might have done it? I'm not sure.
Well, there has to be something correct in it because it's visually I can see the answer.
Yeah.
Yeah.
I'm trying to make sense of it.
Yeah. I guess I looked at it as 3/3 of that third. No, I don't know.
But it's not. It's 3/4. Like those are each little fourths.
Yeah. But it made sense to me when I drew it. So.
Well, and it looks right. That's why I was like, well, this is interesting. So I think what
I
we'll
see it
do,
that way.
Michelle, you've given us something to think about here. We're going to let Michelle continue to contemplate that. And if
Or
Michelle can
Grace
explain
has a
it,
thought.
who has a-
Grace has a thought.
who does?
Grace.
Oh, Grace, speak up. Way to go, Grace.
That's actually how I see it as well. And when I see that she's circling the 3 parts, that is equivalent to like 1/4. So it's like, how many times does 1/4 fit in there? It fits in once, it fits in twice. And the last part, it wasn't, she would still have to count 3 more. So that's why there's 2/3 of that last quarter that would fit into it.
So it's just hard to see that those
Mm,
pieces make 1/4 of the whole.
right.
If you turn it the side though, if you look at the top, like there would
Should
be
we look
like
at yours,
one tiny at the top. Pardon me?
Should we go to yours? Go to number 10. Everybody go to number 10. That was
Yeah,
yours, Grace?
Yeah, 10.
So in number 10, I couldn't circle the top row because that would be a 4. So I had to circle the next one down because what's available. So therefore, it would fit in once, it fit in another time, and then I circled the last part but it wasn't a full fourth, so I only had 2/3 of that remaining fourth.
I get it. I see it now.
Mm-hmm.
I see it now in yours as well, Sheila. I was confused too because it visually wasn't showing me a quarter, but you've counted the pieces to understand out of, like you've done a similar thing to what Caitlin did when Caitlin created the bar of 12. You created an array of 12 and then said, okay, of the 12, 3 pieces would be a quarter. How many times does 3 pieces fit into the 2/3, right? Am I just now talking?
Yeah.
It
No,
makes
that's
sense
exactly
now.
right. Yeah.
Okay.
Yeah.
Whereas back at Caitlin's model, she just had it linear. She was still looking at the 3 pieces because she was saying like 1/4 is 3 pieces of the 12. How many times do those 3 pieces fit into the 2/3? So very, very similar thinking, a different diagram. All right. I love when that happens. That's awesome. Okay. Come on back to your Pear Deck for a second. And now, so Chad, you can see on the right, this is how you can use that number line to show what you were trying to show.
Rhonda, just another thing too is Alicia mentioned that slide 8 in the shared deck also showed a number line that had some success.
Oh, okay. Okay. Does the owner of number 8 want to share with us where you were going with that?
Hey Rhonda, it's Alicia.
Hi, Alicia.
I originally tried using the arrays, as you can see above, and couldn't figure out quite how to show the 2/3 yet. So I jumped into using a number line in the Equatio.
Yep.
So I created my thirds on the first number line. And then knowing I had to find out how many fourths fit into 2/3, I created a number line that showed fourths. And then as you can see, like I circled 1/4, 2/4, and then I had to kind of use the idea of the thirds to know that it was only 2/3 of the way to finding sorry, I lost my train of thought there.
To find the 3rd, 4th. Yeah.
On a 3rd, 4th. Yes. Sorry.
Yeah. And you know what I like that you just said there, Alicia, is that you went back to the answer and you were like, I used the fact that it said 2/3 there to help me develop this understanding. So we're not using this number line in these arrays to get the answer. We're using these number lines in these arrays to help us understand why the answer is what it is. So I love that you said that you went back and you looked at it and you said, well, it must be into third. Oh, now I can see why it would be in thirds. So I love that. Thank you very much. So back to the Pear Deck here. Here's like just an example of one drawn out. And then also the number line over here using that manipulative that Chad was trying to use earlier. So on the right side, you can see at the top of this number line, it's into thirds. So I originally did the same thing that Alicia did and Grace and Sheila and went like, I need a number line that's going to be friendly to both thirds and fourths. So I made the number line into 12ths. You can see on the top where 2/3 lands. And then you can see on the bottom where 1/4 lands, and you can see it goes into 2/3 twice. And then only 2/3 of that 1/4 piece continues into 2/3. And that's confusing because you got 2/2 there. Like this is there's a lot going on in this question cognitively for students to be able to grasp. Do we have any questions around the visuals here or any of the visuals in the classroom slide deck? Okay, good, because I want to give you something else to think about. Same question on paper, whatever you want to do, just how would you solve this using a ratio table or a common denominator? And I'm curious if any of you even knew you could use a common denominator to do a division question and how that might actually even be easier for students to learn that rule instead of the multiply and invert. Back if you left. So if you can understand a ratio table, you will end up understanding why that algorithm of invert and multiply actually works. And again, this idea of a common denominator, what a nice simple thing for students to learn. So if I'm looking at both of these in the sense of 12ths, which is really what you did back in the visuals, most people took it to a 12ths. And I'm looking at this and I'm really asking, well, how many times, let me just choose something a little easier for the sake of my argument here. If I was doing, you know, let's say 2/3 and should never try and think on the spot. I wanted to say 2/3 and 4/6, and I'm like, well, that's kind of, that one doesn't. Let's say 1/3 and 4/6. Okay, if I create a common denominator, I now have 2/6. What did I say? 4/6. It's easy for me as a child to think, how many times does 2/6 go into 4/6, right? That's so much easier for me to grapple with than invert and multiply. Okay, ratio table. So here we go. 2/3, 1/4. How do I use a ratio table? This I learned from my very good friend, Michelle Lang, who's one of the most brilliant people I know. She says, it helps me to think about it in a context. If it takes me 2/3 of an hour to paint 1/4 of a room, how long will it take me to paint the entire room? So my goal is to turn the 1/4 of a room into one full room. So on that bottom row of that ratio table, I'm trying to, what do I need to do in order to get 1/4 to 1? Well, I need to multiply that by 4. Okay. When I do that, I need to multiply the top by 4. And I didn't actually write the numbers in here because I wasn't thinking I was going to do a pear duck. I was going to write them in there with you now. But you can see that that would end up being 8/3 on the top and 1 on the bottom. And now I know 8/3 for one full room, 8/3 of an hour for one full room. And then of course I know that's 2 and 2/3 for one full room. That's what it's going to take me to paint it. So that's helpful. What you've actually done there is the algorithm. Look at what I did. I've taken 2/3 and I've multiplied by 4. My original question was 2/3 divided by 1/4, 1/4. If I was using the algorithm, I would multiply and invert. So 2/3 divided by 1/4 would turn into 2/3 times 4/1, which then would give me 2 and 2/3. So when you actually are doing the algorithm, invert and multiply algorithm, your whole reason for doing that is trying to get that second number in the division question to be 1. And how do I do that? I multiply by the reciprocal of that second. We've just done that so many times that we've taken that extra step out and we just multiply by the reciprocal now. And I can show that to you at another time if you're like, I don't have a clue what this lady's talking about. She's crazy. There's a good chance I am. Okay, multiplication. Let's very quickly hit this. So same thing. If you're familiar with how to do the models, challenge yourself with some technology. If you're not familiar, I want you to just use pencil and paper if that's easiest for you right now. For the array model, Michelle and I were playing with this earlier. You can just on your Google slide use a table to do that. Or you could use Google Draw to do that and do your slash marks like we saw Sheila did her diagonal slash marks. So using it to inserting a table is a great way to create an array. So I'm gonna leave it with you. What time are we at? We are at, oh, I'm gonna give you the 5 minutes again. Maybe 4. Feel free to get a new slide if your division slide got all full. So a really great thing when students are doing this is to use like really great language here. So 2/3 times 1/2 is 2/3 of 1/2. When you get students, what would that, I want you to visualize that, 2/3 of 1/2. So I have a pan of brownies. There's half of the pan left. Half of the pan still has brownies in it. I eat 2/3 of what's left in the half. Giving them a context, giving them a visual helps them develop that operational sense of multiplication. So up to this point, they've probably thought about multiplication as repeated addition or groups. And even though that's still the case here, it's trickier for them to see it with fractions. But if we talk about you're taking 2/3 of a half. Okay, this is time up. And I think I'm going to ask you to come on back to the Pear Deck. I'm just going to show you a couple of examples of what this could look like. Just because it's already 5 to 5. Time goes by so quickly. So using that number line, virtual number line that Chad was playing with earlier, you can see here, again, I chose a number line that was going to be friendly for halves and thirds. And I'm thinking 2/3 of 1/2. So where does my 1/2 lie? This is my 1/2. Okay. Now, what would 2/3 of that 1/2 be? Well, if I take the half and I divide it evenly into 3 sections, I can then see that 2/3 would actually land on 2/6. So that's how you would use a number line to show that. Over here is an array model. So I've taken a square, a rectangle, I've divided it into half, and then I want 2/3 of that half. So I'm taking that whole, I'm dividing it into thirds, and then now I can see, oh, 2/3 of the half is the double shaded area on the bottom here, and I can see that that is 2/6 of the whole. And this Michelle created. So Michelle used Google Draw to create this. So the same idea, I think. Michelle, did you want to just quickly explain what you did?
Yeah, basically I inserted a table and then I just drew the hash marks because I know like by hand it's sometimes quicker and you don't have to then worry about the overlapping colors and changing the transparency, and I just like to do the hash marks in opposite directions to be able to see what's doubly hashed. Gives me that 2/3 of the 1/2, whatever's doubly hashed there.
Perfect. So I hope what you've observed from creating this and proving, as opposed to saying, show me the answer, like you're proving what the answer is how you've maybe developed a better understanding of why the answer is what the answer is, in having to make it visual, as opposed to just following a set of rules to get there. This is an excellent question that we're so sad we don't have time for, but I challenge you at some point to come back to it. And my question, this comes out of Math Up. My question for you, number one, would be, I'll tell you the answer is 2/3. Maybe that will help you. What would be the operation you would do for this? And then how would you go about doing it? Or what would be the visual that you would create for this problem? So this comes from a grade 8 your turn question in Math Up. Challenge you to try it. What it also reinforces is if all we do is teach students to look for keywords in a word problem, or we just teach students algorithm, they've lost their ability to think, because you can't do this question without having mathematical thinking involved and logical thinking involved.
Yeah, and making sense. So when you're doing it, try to make sense of it.
Yes, yes. This is a slide for your own reference for you to read at another time. It is the same slide that we shared with you when we were talking about adding and subtracting fractions. So most of what students are struggling with on this slide talks about adding and subtracting fractions, but the 2 highlighted points relate to multiplication and division. Once again, Michelle has created an amazing sample week at a glance for you to help you get started. It is the first week just to help you get started, and then based on what you've observed in that first week, you would determine how you would move forward with your students in the next couple weeks. According to our WRDSB long range plans, grade 8s have 10 plus days to do this, and grade 7s have 15 plus days to do this topic. The reason for that is technically in a perfect normal year that has not happened in the last 2 years, Grade 7s would come into grade 8 with already an understanding of multiplying and dividing fractions, because they, in our old curriculum, were exposed to multiplying with whole numbers in a fraction and dividing a whole number by a fraction. We can't guarantee that that happened last year, considering we were done in March break and all of the work to rule action that happened before that, the strike action. So you probably in grade 8 will need more than 10 days on this, and you should feel okay to go ahead and do that. You do have a big buffer zone in grade 8, so you have time to spend an extra week on that if you needed to. I also want to point out that in the expectations, we've included the number expectation for the greatest common factor. That's embedded in this topic because it helps when you're getting to a point where you want to simplify fractions. Here's another thing that we do with students. I'm going to just put in one last little soapbox moment for you. Often you'll hear teachers say, I want you to put it in, reduce this fraction to its lowest term. When you say reduce to a student, it means the number is less than what I started with. That's a very confusing thing for students when we're saying, well, no, they're the exact same number, but I want you to reduce it. So we say simplify. We want you to simplify it. And greatest common factor will help with that. So just thinking about the language you're using, and once again, how we tend to confuse students by the language that we're using. Also, there is the developmental tracking sheet, since this is one of our 4 non-negotiables. So it has the adding and subtracting as well as multiplication and division on those developmental tracking sheets for you. Our strategy harvest today, using that green and red square if you're doing synchronous learning with students so they know when they can ask questions and when they need to just pay attention. Equatio is an amazing tool, whether you are doing synchronous distance learning or face-to-face learning. It has so many capabilities for students to demonstrate their thinking with fractions, because even just writing fractions out. Nicole Ronald, amazing educator at Margaret Avenue, shared this student slide deck. I asked her if she had something that she uses with her students to make them get them familiar with the tools of Equatio. She's openly shared that student slide deck with you there. You have that link. Always embedding visual cues is very helpful to our students that have executive functioning as well as students in total. Again, we use Google Slides as vertical non-permanent surfaces, using visual models to build that conceptual understanding. Oh, that shouldn't say equivalency. I'll fix that. And then the Slido to address any concerns. Our next time that we will be getting together is not until February 2nd. It is going to be our coding party. This is new for us in intermediate math and math in general. So we will be looking at how we are embedding coding into spatial sense topic. Always 4 to 5, February 2nd, and it's always the same Google Meet. Okay, so that ends our session. Did we do it? Did I get it?
Yeah, number 1. You did it.
I am going to address the 2 questions that were put on the Slido. You feel free to leave if you need to leave now for whatever reason, or feel free to stay. I'll very quickly show you what those questions are, so maybe you can make an educated decision on whether you want to stay or not. The first one was, can you share real life applications of dividing fractions? And the second one was, could you do an example of how to visually multiply and divide mixed fractions? So I'm going to answer both of those questions. If you are leaving us now, thank you so much for joining us on such a crazy welcome back to what education is now looking like. We really appreciate you joining us, and have a great week. If you are staying, here are some examples. These are both really great questions. I'm really glad whoever asked them. Dividing fractions. Let's get away from recipes. Kids are done with recipes and fractions. Any kind of a rate question. So this first, like we talked about when we were doing the ratio table, it takes me 3 hours to paint 1/4 of a room. How long will it take me to paint the whole room? That's a division question. If I said to you, it takes me, 6 hours to paint half the room, how long will it take me to paint, 6 hours to paint 2 rooms, how long will it take me to paint 1 room? You would understand that that's a division question. Same thing with fractions. So any kind of a rate question, how long will it take you to mow the lawn? How long will it take you to run a certain distance? Anything where you're thinking, how many times would this go into this? So thinking about, I have 1.5 meters of ribbon. I need 2/3 of a meter to make 1 bow. How many bows can I make? Building things. I'm building a series of bike ramps. I need 1 1/3 of a meter for the length of the bike ramp. I found a piece of used plywood in the garage that is 3.5 meters. How many bike ramps can I make? Okay, all division questions. using fractions. So anything you could do with the whole number, just plunk in a division fraction. Do you have anything to add to that one, Michelle?
Nope.
Okay. This one, love that somebody asked this. Can you do an example of how to visually multiply and divide mixed fractions? So if you come back to the meetup, I'm still presenting my screen. I am going to attempt to demonstrate for you how we could visually show this. So I'm going to go to Equatio. I have Equatio open here. This, once you get familiar with Equatio, there's a good chance it will become your new favorite tool. I'm going to do, let me just write it up here. So here I can write in here and just watch how beautiful this works. This is the question I'm going to do. Divided by, let's do 1 1/2. So even for students, when you're trying to put something digitally and you're using that slanted whatever to make the division question, that could be potentially confusing for quite a few students, especially when it's a mixed number. So when you got 1/2, is it 11 halves? I'm not sure what I'm looking at right there. So using Equatio for you yourself to create your slides is a great way. And then I just insert that math and there it is right there. It comes in as a picture form. I can make it bigger, I can make it smaller. Same thing will happen in your Google Slides. So this is the question I'm going to attempt to do right now. So I'm looking at 2 1/4 divided by 1 1/2. So what I'm asking myself is how many times does 1 1/2 go into 2 1/4? So I'm going to use my smart shape down here. I'm going to use a fraction bar. And I'm going to create that into, why aren't my segments showing? Oh, they're there. Oh, maybe the line's weird.
They were there, and then
It's the stroke tools. I had that same problem. It kept going to 0. If you could go down to stroke tools and then, yeah.
Oh, thank you.
Yeah.
I wonder why that's the first time that's ever happened to me. Okay.
Every time I did it, it got rid of them. So then I had to keep doing that. I don't know what the deal was.
Oh, I'm so glad that you figured that out for us. Thank you.
Mm-hmm.
Okay, so this is I'm going to have it in fourths. So here's 1. I'm going to copy and paste that. I'm copy and pasting because I want it to be the exact same size and shape. So there's my 2. I'm going to paste again. And now I'm going to change this because this is only going to be 1/4, not fully shaded in. So I'm going to change that to, I only want 2 1/4 shaded in. So now you can see there's my 2 1/4. I'm going to use the same size again, but I'm going to change it this time into halves because I only need halves. And we'll put both halves can be shaded there because I have 1 full and then I have this guy here. So this is only going to have 1. Okay, so my question is how many times, let me change the colors for us talking. How many times does this blue go into the pink, right? Everybody clear on that? Okay, I can see it goes in once. So now I'm going to create this again. Let me put it over here. Do you see if I fill in this to 2, that's the extra? So here I have 2 1 1/2. I hope everybody can see that. 2 1 1/2. But really it doesn't all go all the way into 2 1 1/2. It only goes to this spot right here. So what is that? I don't know. I'm going to put another rectangle in there to see what that is. And I'm going to make this rectangle friendly for fourths and halves. Okay, so I'm going to make this into 8s. Oh, sorry, fourths. Fourths is friendly for fourths and 1/2. Okay, so I can now see out of my 1 1/2, 1 1/2 would be, I'm thinking it through here, legitimately, live, 6 of these squares. Would everybody agree with that? Your silence is going to tell me, yeah, I totally agree with that, Rhonda. So the unit of 1 1/2 is the equivalent of 6 quarters. Am I making sense, Michelle? Is that sounding okay?
It makes sense to me, yes. And I'm not really,
Nobody's putting anything in there. Okay. So I look at this and I go, okay, here's 1 1/2 goes to here, 1 1/2. I'm still in my pink. Here, I get to here. So I've used 1, 2, 3 out of the 6 squares to get to here. So I've got 1 1/2 once, and then I have it 3 out of the 6 squares. So it must be 1 1/2 is the answer. So 1 1/2 goes into 2 1/4 1 1/2 times. Michelle?
yes, that totally makes sense.
Is that good? Okay. Okay. Now, if I was doing that in, let's say, multiplication, I want to show you this little tool, and you have a link to it. I'll show you where the slide is for the link for this one. It is right here. If you click on this array model, it takes you to this Desmos activity that somebody created. Now, I don't think, you can push back on this, I don't think I would give this to students because it's defeating the purpose of them actually like creating and having to do the thinking to create this. But you could use this as a demonstration tool to show students something. It looks a little bit complicated at first because it's not refined. Some teacher just made it. The A, B here is your first fraction. So say I was doing, well, let's do the same one. No, let's do a different one. Let's say I was doing 1 1/3. So 1 1/3 is 4/3. So my first fraction is 4/3. So the denominator is 3. So you can see it here, AB. I'm going to take all this off there. Okay, so you see 4/3 there. That's what you're seeing. And my second fraction, let's use 1 1/5. So 1 1/5 is 6/5. So my second fraction, I'm going to make into 6/5. So there's my 6/5. I can turn the shading on for that. And so now I can see at any point I can explain, okay, here's my 4/3. So here's 1, 2, 3, that's 1/3. This is 4/3. Okay, turn that off. Here's my 6/5. This has been divided into fifths. I have my 6/5 up here. When I multiply those two things together, so I'm asking what is 1 1/3 of 1 1/5? This is my answer right here, this overlap area right here. And if I wanted to see that in a different color, I could click down here and then it's going to make it that color. Or if I wanted just to be able to see it overlapping. So now I can see, oh, out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 1, 2, 3, 4, 5, 6, out of the 30 squares here, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 24 of them. 24 out of 30 is my answer.
No, careful, because you're not looking at the whole. You were looking at more than one whole.
Oh my gosh, you're so correct. Thank you. Right. So the whole would be just one of these squares here. 1, 2, 3, 1, 2, 3, 4, 5. So 15, right? Am I right, Michelle?
I think so.
Yeah. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 24 15ths. Yeah, that makes sense because it should be bigger than 1, 2.
Is it though, or are 2 squares the whole?
No, I think it's just the 1 square.
If you turn off the
Okay,
stuff, like, yeah, and now see, it's 2. You've got 2.
But it goes 2 because it has to be 2 going this way as well. Like
I know,
going,
but I think 2 squares is one whole.
it's small. See? Like if I make them both improper fractions, it would just be that. So it's because
Right.
it needs to go above horizontally and above vertically. So it
Right,
makes-
but what is your whole then? So if you make that again, make that 6/5 again, the second fraction. The whole now is 2 of those squares, right?
No, it's just the overflow because
No,
it has to overflow horizontally here, and then it has to overflow horizontally here.
Right.
So this is still just the whole.
No, I don't think so. I think right now it's the horizontal, those 2 squares are the whole, and it's vertical 2 squares are the whole for the other fraction. What's the answer supposed to be? So it's 4/3 times 6/5?
Yeah, so 24/15.
So yeah, put it all on.
So this is the whole.
Well, that's confusing to me.
Yeah, it's confusing whenever you go above 1. That's why I was so happy somebody asked that about a mixed number. But it's just because this square got added on because when I was making rows, I needed this extra one. And this square got added on because when I was making, when I was making columns, I needed it over here. When I was making rows, I needed an extra one up here. But this is the whole here.
Okay, and the solid black makes it look like the whole.
Yeah. Are there any other questions about that? I think we should probably call time of death on this one. 5:15. Okay, I'm going to stop sharing. We still got people with us. Wow. Pardon?
With us. Any questions from those of you who are still with us?
We kind of forgot that there was other people watching. Yeah, any questions from anybody? Please feel free to unmic or put it in the chat, whatever works best for you.
And otherwise, thank you very much.
Yeah, and if you're super confused about anything, like you want more information about Equatio, you need a little bit more practice. In the slide deck that I share with you, there's some more practice questions for you to work on your own to get fluent with it. But by all means, reach out to Michelle and I, and we will make sure that we connect with you to help you out on that.